Welcome back. Chapter 1, Section 6. We're going to talk about how to write the equation of a line. Okay, and there are basically three situations that we're going to kind of look at that you have to understand what to do in each situation, but they're fairly simple, so let's go through them quickly. What if you are given the slope m and the y-intercept b? Okay, so in order to write the equation of any line, if you knew these two things, the slope, which is a measure of the steepness, we also know this is the rise over the run from a graphical perspective, but what the definition of slope actually is the change in y over the change in x. But if we knew this and we knew where it crossed the y-axis, that's called the y-intercept, then basically it's a matter of taking this value m and this value b and simply plugging them in here and here to get your answer. So this is going to be the easiest situation. We'll look at an example of that. Another situation that will come up sometimes is maybe you know the m, the slope, but you don't know the b, the y-intercept. In this situation, you're going to have to know one other point somewhere on the line, which we're going to generically call x1, y1. And in that case, you can use what we call point slope form, where it's basically y, which is the same y right here, m, which is the same m here, x, which is the same x here. The difference is you're going to take this point x1, y1, and you're going to plug it in here for x1, y1. And then you can basically solve this to put it back into this form, y equals mx plus b. So it's called point slope form because you're going to know one point and you're going to know the slope. So you can use this form in that situation. And the third, which is usually the most challenging, I will make very, very easy today, is what if you just know 2 points on the line? So you don't know m nor do you know b. Well, in this situation, we can basically use the slope formula to find the slope, which what is the slope formula? Well, it's the change in y, so you're going to subtract your two y values over the change in x, so you're going to subtract your two x values, and that ratio is m, your slope, and then you can basically take m along with one of these points, and it doesn't matter which, and plug it into this formula, which will let you simplify down to this formula. But also there's a second way to attack this one with your calculator that you're going to like and probably use more often than not. So we'll look at both of those. All right, so in example 1, it says the graph shows the distant asteroid 2012 DA14 traveled in x seconds. So let's just take a look at this real quick. On the y-axis, we have distance in miles, and on the x-axis, we have time in seconds. So here's a little quick heads up. When you're doing slope, m, it's always the change in y over the change in x. So it's really easy to figure out what these represent because on the y-axis is miles, and on the x-axis is seconds. So if you say, what is miles per second? That's the change in y over the change in x, miles per second. Well, that would be the speed of something, miles per second. And so this thing is obviously moving. When you're measuring how many miles something travels every second, it's moving. But if you look at the graph, I want you to notice it starts at the origin, 0, 0, and it has a point on it at 5, 24. Now, when you're finding the slope, you want to find two good points. This is a good point, and this is a good point. So what's the slope of this? Well, if you've started here at 0, 0, you're going to rise 24, and you're going to run 5. So in other words, because this goes to the origin 0, 0, it's literally just the y over the x here. Because the change from 0 would obviously be 24. The change from x, 0, would be 5. So 24 over 5 is our slope. So it says the asteroid came within 17,200 miles of the Earth in February 2013. How long, or excuse me, about how long does it take the asteroid to travel that distance? So this is the distance I'm interested in. So if I found the equation, let's start with what's m. Well, we've already discussed it. It's 24 over 5, which if you want to reduce this to 4.8. Now, what does that 4.8 actually mean? Well, that's 4.8 miles every second. So almost 5 miles per second. This thing's moving pretty fast. Now, what's the y-intercept? Well, look at the graph. It crosses the y-axis at 0. Okay, y equals 0. So my y-intercept is 0. So I have my equation, y equals mx plus b. I know m is 4.8. I know b is 0. So the equation is y equals 4.8x. Now the question is, how long does it take it to travel? How long? X, solving for x. Distance is your output, your y, 17,200. Well, I can simply plug it in. 4.8x equals 17,200 miles. That's a y value. And then divide both sides by 4.8 to solve for x. And notice what you get is 3,583. Okay, now that's seconds. So that's a kind of a big number. So if you want to put that in maybe a number that makes a little bit more sense, if you did 60 times 60, that would be 3,600 seconds for every 1 hour. So notice this is a little bit under an hour. So in under a little bit of an hour, it can travel basically 17,200 miles. So now put that into perspective. That's 17,200 miles per hour. And like I said, that's moving. That's pretty fast. All right, so as we keep moving along, in that situation, we knew basically M and B because we could pull them right off the graph. You can find the slope here. You can find the B there, the y-intercept. Let's take a look at example 2. All right, 2 prom venues charge a rental fee plus a fee per student. So this is a common situation. 2 different places, 2 different fees, okay? One's going to have a fee per student, and one's going to have a different initial fee, or how much you have to start up with. The table shows the total cost for a different number of students at Lakeside. So here's the data for Lakeside. So for 100 students, it's going to cost us $1,500. For 125, $1,800, et cetera, et cetera. You can kind of go through this and see what's going on. There's a different place. The total cost y in dollars for X students at Sunview Resort is represented by y equals 10x plus 600. Now, what I want to do is just start with explaining a common thing that comes up. Because slope is a rate, it's the change in y over the change in x, then that word per comes into play a lot, something per something. So when I see this 10 here, which y equals mx plus b, 10, this 10 is going to represent something per something. And in this case, our y values are dollars and our x values are students. So see the 10? That's $10 per student. That's what this slope is going to represent, 10 bucks per student. What does the y-intercept represent? Well, the y-intercept, if you think about it as an ordered pair, is going to be 0, something. The x value is always going to be 0. So here, when x is 0, that's when you have no students. This is basically going to be, for no students, that would cost $600. Well, what does that mean? We wouldn't have a prom with no students. Well, that means this is some sort of a startup fee. So this is going to represent, it's going to cost us $600 like to reserve the place, or $600 deposit just to have the prom, plus $10 per student. So you guys are used to this kind of thought process where there's some fee for having something plus it's a rate per whatever. And so for Sunview, it's $10 per student, $600 to reserve the place, okay? So the question is, which venue charges less per student? So that's a slope question. Now I know this one's 10. I can find this one, and I will in just a second. How many students must attend for the total cost to be the same? Well, that'll be easy because once we get an equation for this, we can more or less just set them equal to each other and solve for x, because that's when the y values would be the same. So let's kind of go through this. I already know the equation here. Let's find the equation here. All right, so the first thing is let's find the slope. So we need 2 points. And here's our slope formula, change in y over change in x. So if I chose the first 2 points, I do 1,800 minus 1,500 is 300. 125 minus 100 is 25. 300 over 25 is 12. So there's your slope. So I already know that this place is going to charge $12 per student. This one was 10. So I already got part of my answer. Sunview here is going to be less per student. This is going to be more per student. But it doesn't mean it's going to cost more in the end because it depends on how much the initial fee is. So now that I know that this is 12, I can take and plug into this formula. I just need one other point. It doesn't matter actually which of these you chose. They chose to use the first one. So here we go. I know my m is 12, and if I use 100 and 1,500 respectively, x minus 100, y minus 1,500, what I can now do is solve this. So what you would do to solve it, remember, is this is a distributive property. So you do 12 times x is 12x. 12 times 100 is 1,200 because that's minus. This is also minus. And then here, to finish this out, I'm going to add 1,500 to both sides. So negative 1,200 plus 1,500 is 300. So here's my equation. So notice if I were to now compare these two, this one had a slope of 10, a y-intercept of 600. This one had a slope of 12, a y-intercept of 3. So this is more per student, but it costs less at the beginning. See, 300 is less than 600. So really what we're looking at is, how long is it going to take to make up this difference of $300 when this one costs $2 more? But where we can solve that is basically take this equation and this equation. They're both equal to y. Just set them equal to each other and solve for x, because the question is how many students for the cost to be the same. So solving for x here, if I set this equal to this, I would subtract 10x from both sides. 12x minus 10x is 2x. I would subtract 300 from both sides. 600 minus 300 is 300. Divide both sides by 2, and your answer is 150 students. Why? Because 150 times that $2 is 300, and that's where you make up this extra $300. $2 more per student. It'll take 150 students to make up $300. All right, so that is essentially how we would do that. Now, if you want to check it, plug in the 150 into both of them, and you'll see that both of them would equal $2,100. All right, so we have a situation here where we needed to find the slope, and we were just given some points. I'm going to show you another way to attack this style of problem in just a moment, but let's keep the party going. All right, so when we're graphing, we a lot of times are going to use our calculator, but you can also do this, with your calculator, but you can also do it by hand. And so we're going to look at the idea of a scatter plot and doing it maybe in the calculator. So what are we going to do? To find what we call the line of best fit. This is a line that approximates the data the best. Now, the line of best fit is not going to go through every point, because generally you're dealing with some sort of a data from the real world where it's not a exactly perfectly straight line, but you can still use this logic to help you out. So here's an example of making a scatter plot and then drawing the line of best fit and then finding the equation, okay? So here's a situation. The table shows the femur length. So this is the length of the big bone in your body, which runs from basically your hip to your knee, and a person's height. Now, there should be some sort of relationship here. I would think that the longer a person's femur, the taller they possibly might be. And for the most part, that's true. And so as we kind of graph this, keep in mind that as x gets bigger, and these are not in any particular order, if you'll notice, as x is going to get bigger in a moment, if we put these in order, the y, for the most part, is also going to get bigger, because generally the longer your femur, the taller you are. All right, so as we do this, if you went and plotted all of these points on a graph, 40, 170, so you go over 40 and up to 170, put a point. 45 and 183, so go over 45, go up 83, put a point. So you plot all of these points on an actual piece of graph paper. You would notice that for the most part, the rule is what I said. As the femur length increases, the height does. And it pretty much forms a line here. So you would literally take a ruler out and draw a line that kind of goes right through the middle of this data. All right. Now, once you draw that line, to find the equation, you're going to need 2 points. Now, it just so happens that these 2 points, 40, 170 and 50, 195, which are in our data table, also appear on that line. So you could use those points. And then you would find the slope. Okay, using the slope formula, here it is. But here's another way to look at this, guys. If you went from 170 to 195, what's the change? The answer is 25. If you went from 40 to 50, what's the change? The answer is 10. So 25 is the change, 10 is the change. So 25 over 10 is 2.5. That's going to be our slope. So once you have your m of 2.5, now choose one of those points. They chose this one, and plug it in. X1 here is 40. Y1 is 170, and then again, just solving this thing, distributing your 2.5 to both of these, and then basically you would have 2.5 times x, 2.5 times 40 is 100, add a 170 to both sides, and you get this lovely equation here, which we know the slope is 2.5, we know the y-intercept is 70, but the question is, do they show linear? Yeah, obviously they do. And then estimate a person's height if their femur is 35 centimeters long. Well, now that we got our equation, that's really easy. Just plug in a 35 for x. Their height would be around 157.5 centimeters. Okay. Now, this is, again, what we use this for in the real world. If there's some sort of relationship, if we can quantify it into some sort of equation, then we can predict what should happen. And this is the same way that doctors tell a mom when their child is really small based on their height and their weight. When they're, say, 3 months old or 5 months old or a year old, they'll say your son or your daughter should be this tall whenever they are, 16, 17, 18 years old. They're estimating their height based on data that's known, that's been collected for years, to generate some sort of an idea of how tall you should be. It doesn't mean you're automatically going to be that height, but it does give you an idea of how tall you should be if you follow the average pattern that normally happens. All right, so what I want to look at is this idea is we can do this by hand, but we can also do this in the calculator. So I want to show you guys something real quick. if you want to create a scatter plot in your calculator, you go to Stat, and then we're going to Edit, and you have these lists, L1, L2, L3, L4, okay? List 1 can be our X values. So I'm just going to choose a couple of these, okay? 40, and then let's go maybe 45. And those are my X values. And then let's go 170 and 183. Now, if you wanted to get the exact answer in this situation, you would actually need to do all of these. But just for the sake of time, I'm just going to do 2 of them. So this is my X and this is my Y. Okay, if you want to see what these look like, you got to, what we do is say turn on your stat plot. So notice stat plot's in blue. If I hit second Y equals, and then number 1, I'm going to turn this on. And here tells me what I want it to look like. I want it to be a scatter plot. And then L1 is going to be where the X is, L2 is the Y, and then I want the mark to look like this. And then if you do have color, this one would be color. All right, now one other thing is, if you look at the data that we entered in, the X values are really, not around 0 to 10, so we're going to need to change our window. But if I went here to my window, and let me say, looking at this data, let's maybe go from 25, a little bit below that 30 that I see right there. And then this goes as high as, let's see, 50. So let's go to maybe 60. And then on my Y values, I'm going to count this by 5. So it's going to put a mark every little 5. All right, my Y values are way up there, okay? So 170, 183, 195. So maybe let's go from 100 on the min. And let's take this all the way up to, I don't know, 200. That'll get it, or maybe 210. Let's go 210. All right, since I've turned my stat plots on, let me count these by, I don't know, 10s maybe. Since I've turned my stat plot on, okay, and I put that data in stat edit, now when I go to graph, you're going to see it actually generated those 2 points. Now you can see where I can now create this scatter plot by going to stat edit and just put all the data in there. But again, just for what we're looking at, graph, this is good. Now, it will actually find the equation of the line that goes through these 2 points. And this is something you can use on a lot of questions in this. If you know just 2 points, you can find the line. So let's go to stat. And this time we're going to right arrow over to calculate. And we know it's linear. So let's do number 4, a linear regression. Number 4. Notice it says we're going to pull X's from list 1, Y's from list 2. And there's some other things that it do. But just to simply get the equation, you go down to calculate and hit enter. And then notice it gives you the equation. Now, how did that equation relate to the one we came up by hand? Well, the slopes are close, 2.6, 2.5, those are close. Y-intercept 70, 66, it's close. And so here's the deal, though. If you know just 2 points, then this will be the exact answer. So if you've got a question that only gives you 2, that's going to be the answer. Now, what I could do if I wanted to is I could go here and, type that in, 2.6 X plus 66, and then graph it, and it is the line that goes through those particular 2 points, okay? It's always going to find the line of best fit, so if you put all the data in, it would change a little bit, but it should be relatively close, okay? All right, now one other thing to talk about, and I know this might be new to some of y'all, is let's say that I get rid of this for a second, clear that out, and let's quit, and then again, let's go to stat, calculate. One other thing your calculator will do that I want to show you today anyway, is if you choose number 4, instead of going all the way to just calculate, stop here. All right, if you hit alpha trace, it brings up what we call the Y-vars menu, and you can select number 1 by hitting enter or the number 1. And notice it says store reg EQ. Well, that stands for store the regression equation in Y1. So once you run the regression here, calculate, not only does it calculate it, but it also types it in for you. Now you can use it to estimate, guess, whatever you want to do in a question. But again, this is how you would basically put these in the calculator and find the equation of the line. Because notice when you run the regression equation, so that's stat, calculate, in this case we're doing number 4, and you calculate that regression equation, it is giving you what they call the A and the B. But what is the A? Well, Y equals mx plus b. The A is actually the slope and the B is actually the y-intercept. So any question that asks you for the slope and the y-intercept, if you have 2 ordered pairs, 2 points, this is a method that you could actually use to come up with your answer. All right, so as we move on, we want to talk about one other thing, okay? The line of best fit, I actually showed you how to do this. It's called the linear regression feature in your calculator. But there's another number that's somewhere between -1 and 1 that's called the correlation coefficient. And here's the deal on this one. The closer this number is to the number 1 or -1, the better your line is actually going to fit. And what I mean by better, well, think of this 1 as like 100%. And the idea is the closer it is to 1, it's like 100% accurate if it's at 1. So if it's at like 0.99, that's like 99% accuracy. It means that the ordered pairs are really close to forming a perfectly straight line. All right, but the reason why we use a 1 and a -1 is this is if it has a positive slope. The closer it is to -1, the closer it is to a negative slope. So if you borrow some terms back from middle school, we're talking about positive correlation, negative correlation. Now, what if R is close to 0? Well, what that would mean is there's no relationship between X and Y. That means the points are spread all over the place, and it doesn't really look like a line. It's really scattered, so your scattered plots all over the place. So we call that no correlation. So here's an example of how we could do that in our calculator. Let's take the same problem from a second ago, but notice they're going to actually put these all in here, and then I'm going to show you how to come up with this R value, which we call the correlation coefficient. So to enter the data into your calculator, we already discussed that. All right, we would go to Stat, Edit, and in this particular case, you would actually want to enter all of these ordered pairs in here. So every single one of these, I'm not going to do them all just for time's sake, but you would type all these in here. Make sure that the X's and the Y's that go together are next door because these are ordered pairs. So the 45 goes with the 183, the 32 goes with the 151, etc. All right, once you get those in there, then you're going to run the regression. So that was, let me go back to the calculator, just refresh your memory on this one. Second quit, go to the home screen. You're going to go Stat, and you're going to calculate, and it's number 4. All right, and then if you want to store the regression equation, you can stop here and hit your alpha trace 1, and then you calculate. All right, now that's going to give you the M and the B, the A, in this case they call it A, but it's the slope and the y-intercept. Now, what is this correlation coefficient? How do I get it? Well, there's something you need to do in your calculator real quick. You need to go to Mode, and what I want you to do is go down here to where it says Stat Diagnostics. So go all the way to you see Stat Diagnostics, and turn this to on. So it's highlighted, so go over here with your cursor, then hit Enter. Now it's on. Now quit, second mode, get out of this. Now this time when you run your StatCal 4, not only is it going to run the regression, but it's going to give you extra information. All right, now notice here the R showed up. Now my R is 1. That's a perfect correlation. Why? Well, look, I only had 2 points in mind. It is the line of best fit that goes through those 2 points. Let's look at what they did, and you'll see the difference. If you put all of these in there and ran the regression, notice the points aren't all on a perfectly straight line because this is the line of best fit. Okay, it's not the perfect line. So what does that mean? Well, they're all pretty close to this line. So look at your R value, 0.99. Well, that's pretty stinking close to 1. So think of that as like 99.4% accurate. So this line should be accurate 99% of the time. So that means most of the time, more often than not, the data will end up somewhere really close to this line. And you can see that. Those are clustered really close to that line. Now we can get our second answer. Estimate the height of a person whose femur is 35 centimeters long. Well, take our new equation and plug in a 35, and you get 156 centimeters. Now, how does that compare to doing it by hand? Well, we got 156 in the calculator, and we got 157.5 by hand. So that's the deal. Anytime you're doing this by hand, everybody might get a little bit different answer. But if you're doing it in the calculator and you do it right, everybody should get the same answer. So using a computer is obviously better than doing it by hand. So when given the chance to make a scatter plot, you know, it would be best to use your calculator. If it says do it by hand, then obviously you could do it by hand, but we want to use the calculator as much as possible so that we're getting the same answer, number one, but number two, a more approximate answer, because the calculator uses a systematic way of doing this, where it's measuring distances from this and actually finding the line of best fit. Okay. All right. So that's pretty much it. You should be ready to start your exercises. So if you have any questions, let me know. But it's pretty heavy on the calculator, so use it as much as possible.